Let's take a look on one of the most powerful features of HQBird, performance report. Performance report is based on trace logs. Trace logs and trace as a feature was introduced in Firebird 2.5 and remains the main feature and the main source of performance information. It is critical to analyze trace logs in order to see and in order to fix problems with performance. The performance report consists of several sections. There are top graphs, there is an overall graph, and there are several perspectives, several dimensions of queries, of analyzed queries, which represent the different parts of the database load. I would like to demonstrate how it is possible to quickly identify the problems in this using this demo report as example. When I first open the report, the first thing I would like to understand is there any time pattern, or let's say some changes during the day which represent some peaks or some problems. For example, in this report, we can easily see that there is some time when the load of the database was particularly higher. And if we will remove all information from the graph, we will see that the problem, the possible problem in the frequency of these reports. So usually it was like 40 something, and at this period it became like 140 something. Also there was a short period in the morning, about 10, about 11, when the number of executions was even higher. After that, I quickly jump to this section. So this section represents dimensions or perspectives of analyzed queries. For example, if we have a lot of queries and some of them are not very long, not very slow, let's say, but there are a lot of them, we should identify these queries first. For this purpose serves this perspective, call it plan summary, and also its twin brother, time summary. So plan summary and time summary. What is the difference? The plan summary groups all executions around the execution plan of the query. So here we can see this plan, and here is the query which corresponds to this plan. So first of all, we need to take a look for this information. So it shows the percent of the time, of the total time of all executions. And here's a representation in milliseconds for the period when the login, when the tracing was active. And we can see that 20% of all the time was spent executing this query. So the system spent 20% of all time executing this query. There were this number of repetitions of this query, and it represents 24% of all executions for the logged period. Well, so it means, but for this example, it is pretty easy to see that this query is actually the most problematic query for this database, because it represents such a big percent of execution time, and also it represents the big percent of frequency. it's pretty frequent, like 25 of all executions is this query. And we can take a look on the details of this query. Here we see individual graph when this query, with this plan was executed. And as you can see, the execution of this query is the same. The time when this query was executed is the same when we have seen the top, the spikes of the load on the overall graph. Let's return to overall graph and see this one. This is our query. Now let's return to the query number 1 in plan summary and see how we can understand why this query is problematic. First of all, we need to confirm is this problem is a kind of general problem. And for this we have statistics, execution statistics. So we can see that this query was executed 4,428 times. The minimum time was 351 milliseconds. The maximum time was almost 4 seconds. And average time and median time is like 457, 455. So it means that this example, which demonstrates the maximum times, almost 4 seconds, probably is a good example to be optimized. So we can get the text of this query, we can get the parameters for this query, and analyze it using some tool to see why there is such a problem with executions. After that, we can also return and see the other metrics for these queries. So fetches, operations with cache, you can see that in average they are pretty low, like 7,000 fetches it is not much. We can see that also that maximum is not so high. Usually such situation occur when we have sorting, and here we have the order plan. So, but anyway, the optimization of the specific query is the different task. So here we are identifying the most problematic queries, and after that, these most problematic queries should be submitted to developer or to the DBA for optimization. Well, if you don't have experienced developer or DBA with capabilities to optimize queries, of course, you can consider to hire IBSurgeon services, including newly introduced service for optimization of queries, also available in the calculator portal. But let's continue with identifying with analysis of this report and with identification of problems with queries. So we reviewed the plan summary. Number 1 represents 20% of all executions. Let's take a look on number 2. Number 2 represents like 8% of all executions. There is some query which usually shows us how much. Median 400 milliseconds, average 680 milliseconds, and we can see that this query is well distributed. So it occurs during the day and repeats from like 10 times per minute, 5 times per minute, 8 times per minute, and so on. So looks like normal work. And of course, when we are selecting the target for optimization, we need to start from the the biggest problems. In this example, in plant summary, the biggest problematic query will be this one, which we already discussed. However, from the perspective of users, it is possible, but users will tell that there are some specific queries, some specific operations which are slow, and you should somehow identify them and optimize. For this purpose serves duration. What is the duration? The idea of using duration of queries as a specific dimension to identify the longest queries is really simple. And of course, we need to see queries which are, the top, the number one, the longest query. And in this example report, we can see that we have query which is ranked 1 of 18,000 overall queries, number 1, and it has duration 77 seconds. It is in milliseconds, but 77 seconds. So this query actually is a stored procedure. Here is the parameters for this procedure, and we can see that it returns 1008 records. And it took 77 seconds to execute it, and a lot of fetches. Looking at the execution statistics, we can see that here in the table change vendor, we have a lot of natural reads. A lot of reads, and probably this is the problem why it is so slow. We can scroll down and see number 2 of the overall executions. We can see another storage procedure, also 77 seconds, slightly different number of records, but again it reads the table change vendor in natural way without index, and probably inside this procedure there is some problem with index. This table probably does not have the proper index for fast access. Number 3, 76 seconds, returns 263 records, and again we see the same problem with change vendor. It has a lot of natural reads. Number 4, almost the same. There is not so much records returned. If, for example, if we would see here millions of records fetched, it could explain the duration of such query, because the fetching records and transmitting them, it actually takes time, especially transmitting over the network. But if we see a relatively low number of records fetched, but pretty big number, pretty long duration of query and a lot of fetches, and combined with a lot of natural reads, most likely this is the problem. Number 5 of the most longest queries, some pretty big query, but only 13 seconds, returns 500 records, performs some operations, nothing obvious, but we can see there are some suspicious things like a lot of left joins, this condition, and it seems there is some room for optimization. For this query. Number 6, 20,000 records returned for 10 seconds, some number of reads, operations, and so on. So using the duration, we can identify the individual queries which represent the problems. And if, for example, this query is some kind of big report and it runs like every month, maybe you can postpone its optimization and optimize first the queries from plant summary and other reports, other long queries. But if this report is pretty frequent, or if users specifically mark them as a problem, you can go optimize it. The next thing in this report is a process summary and client address summary dimensions, points of views. Let's click on process summary. Here we can see the operations like attachment, detachments, connections, number of operations, total duration of all queries, number of fetches, and so on, grouped by the processes, by the process names. So we can sort and see that the number one process, which generates a lot of queries. So we can see the number of operations, number of queries, total duration is pretty big, is this one. And it corresponds with what we have seen in the plant summary. We can see that there is also another one in terms of fetches, and it does not have process name. Well, it means that this application, this client application, uses old FB client DLL, which also is a problem. It can decrease the performance. Also, it can use some old version of Firebird.net or JBird, Java drivers, and so on. So the new client should have the executable name here in the process. The next perspective, the next point of view, is client's address summary. Client's address summary is really important when you are analyzing the impact of the load which comes from some specific workstations. If you suspect that one of the workstations, one of the addresses generates a lot of queries, or it generates unusual load, you can use this client address summary to identify what workstation generates load. Also, it will show you the list of executables which are accessing from database from this specific address, and other summarized metrics. No, unfortunately, in this specific example report, we don't have a lot of addresses, but if you are using classical client server configuration, when you have one server and a lot of clients, the client's address summary report dimension will certainly help you to understand how the load is distributed among workstations, among addresses.